Proof by contraposition is a valid method of proof in mathematics. It involves assuming the negation of the conclusion and then proving that it implies the negations of the hypothesis. If this application holds true, then the original statement, the conditional statement, is also true. Prove the statement if x is an even integer, then x squared is even. Let's denote the given statement as f p then q, where p is x is an even integer and q is x squared is even. To prove this statement by contraposition, we need to show that the negation of q implies the negations of p. Step 1 negates the conclusion q. The negations of x squared is even, is x squared is odd. Step 2 assume the negated conclusion assumes that x squared is odd. Step 3 prove that the negation of the hypothesis P follows from the assumed negated conclusion. We need to show that if x squared is odd, then x is not an even integer. The negation of x is an even integer. Proof 1. Assume x squared is odd. 2. By the definition of an odd number, x squared equals 2k plus 1 for some integer k. 3. Taking the square root of both sides, we get x equals square root of 2k plus 1. 4. Since the square root of an odd number except 1 is not an integer, x cannot be an integer. 5. Therefore, if x squared is odd, x cannot be an even integer. Step 4. Conclude the proof by contraposition. Since we have shown that the negation of q x squared is odd implies the negation of p x is not an even integer, we can conclude by the principle of contraposition that the original statement, if x is an even integer, then x squared is even, is true. Explanation. In the proof by contraposition, we assumed the negation of the conclusion x squared is odd and prove that it implies the negations of the hypothesis. X is not an even integer. By doing so, we have established the truth of the original conditional statement without directly proving it. The proof by contraposition is a valid method because the conditional statement, if P then Q is logically equivalent to its contrapositive, if not Q then not P, therefore, proving the contrapositive form establishes the truth of the original statement. Proof by contraposition is particularly useful when it is easier to work with the negated conclusion and show that it implies the negated hypothesis rather than directly proving the original statement. So that would be all. Thank you.